Welcome to G Fun Facts Online, where today we're looking beyond the familiar flash and crackle of a thunderstorm to uncover a phenomenon of truly epic proportions. For centuries, we saw lightning as the fury of the gods. Today, science has tamed that myth, but the atmosphere keeps revealing new, more powerful secrets. We're not talking about your average lightning bolt, we're talking about megaflashes. These aren't just flashes, they are continent-spanning behemoths, the absolute titans of terrestrial electricity, stretching for hundreds of kilometers across the sky in a single, silent, sprawling spectacle. So what exactly is a megaflash? The formal definition from atmospheric scientists is a single, continuous horizontal lightning flash that extends for more than 100 kilometers, or about 62 miles. But that simple definition doesn't do it justice. Most lightning is contained within a dozen or so kilometers. Megaflashes are in a completely different league, often spanning entire states and lasting for an astonishingly long time. These are not the bright, vertical cloud-to-ground strikes we're used to seeing. Instead, think of a megaflash as a vast, intricate network of electrical pathways spreading horizontally through the clouds. It's like a colossal chain reaction, a cascade of electricity that can trigger hundreds of individual ground strikes along its sprawling path. If you are on the ground, you might not even realize you're witnessing one. You might just see a prolonged, flickering glow inside the clouds, a silent, pulsating light. This subtlety is what makes them so dangerous, leading to what's known as a bolt from the gray. A sudden ground strike from a seemingly distant, non-threatening cloud, far from the storm's core. So where do these giants come from? Megaflashes aren't born from ordinary thunderstorms. They require a very specific and immense cradle, a Mesoscale Convective System, or MCS. An MCS is a sprawling complex of thunderstorms that organizes on a scale far larger than any single storm. These behemoth systems can cover an area the size of a large state, like Ohio or Kansas, and can persist for hours, even days. Within these vast, turbulent systems, the conditions are perfect. An MCS is characterized by a large, overhanging anvil, the flat, spreading top of the thunderclouds, and extensive regions of stratiform rain. It's within these expansive, electrified cloud shields that megaflashes find the space they need to grow and travel over such extraordinary distances. Think of a thunderstorm as a giant, natural battery. Updrafts and downdrafts separate electrical charges, making the top of the cloud positive and the lower and middle regions negative. A megaflash is essentially a massive horizontal short circuit within this sprawling atmospheric capacitor. For one to form, you need these huge electrified clouds to be discharging at a relatively low rate. This allows a single horizontal flash to keep propagating, unchecked, for hundreds upon hundreds of kilometers. It's a testament to the immense electrical potential that can build up. And it's a rare event. Less than 1% of all thunderstorms are believed to produce megaflashes. The conditions for these electrical giants aren't found everywhere. There are two primary hotspots on Earth. The first is the Great Plains of North America. This region, stretching across the central United States, is a notorious breeding ground for severe weather. The unique geography, with the Rocky Mountains to the west and warm, moist air flowing from the Gulf of Mexico, creates a volatile atmospheric cocktail that fuels the massive mesoscale convective systems. The second major hotspot is the La Plata Basin in South America, covering parts of Argentina, Brazil, Paraguay, and Uruguay. The convergence of moist air from the Amazon rainforest and the Andes Mountains helps form some of the most electrically active storms on the planet, creating the ideal environment for megaflashes to ignite. Our journey to even understand these phenomena is a story of incredible technological progress. For centuries, lightning was pure mythology, the weapon of Zeus or Thor's hammer. The science began in the 18th century with Benjamin Franklin and his famous kite experiment, which proved lightning was electricity. For most of the 20th century, we were limited to ground-based observation. We learned that lightning produces radio waves, or spherics, which allowed us to map activity over larger areas. But these systems were best at detecting cloud-to-ground strikes and had a limited range. The true scale of these massive horizontal flashes remained hidden, hinted at, but never fully measured. The real game-changer was sending our eyes to space. Starting in 2016, instruments like the Geostationary Lightning Mapper, or GLM, aboard the GEO series of satellites gave us an unprecedented view. These sophisticated mappers continuously track both in-cloud and cloud-to-ground lightning across entire continents, day and night, with incredible resolution. It was this new eye in the sky that finally allowed scientists to see the true, breathtaking scale of megaflashes, confirming their existence and allowing us to officially recognize these awe-inspiring events. And the records being set are simply mind-blowing. The World Meteorological Organization, the official keeper of these records, has certified some incredible events in just the last few years. Let's talk about the longest flash ever recorded. This behemoth occurred on October 22, 2017, and stretched an incredible 829 kilometers or 515 miles across the southern United States. It originated in eastern Texas and extended all the way to near Kansas City, Missouri. To put that in perspective, it would take a commercial airplane over 90 minutes to fly the length of that single lightning flash. What's even more fascinating is that this record was only identified in 2024 after a reanalysis of old satellite data. We're still discovering the titans that have already occurred. This shattered the previous record of 768 kilometers, also set over the US. Then there's the duration record. The longest-lasting single flash flickered continuously for an astounding 17.102 seconds. It happened over Uruguay and northern Argentina on June 18, 2020. Imagine watching a single lightning event illuminate the sky for over 17 seconds. These records aren't just for trivia. They are vital data points that help scientists understand the absolute upper limits of what is possible in our atmosphere. And as our technology improves, it's almost certain that even more extreme megaflashes are out there, waiting to be discovered. While they are a source of scientific wonder, megaflashes also pose significant and often underestimated risks. The biggest one comes from that bolt from the gray phenomenon. Because these flashes travel hundreds of kilometers horizontally, they can produce a cloud-to-ground strike in an area far from the storm's heavy rain and thunder. You could be on the ground, under a seemingly benign overcast sky, with no audible thunder, assuming you're safe. Then, suddenly, a deadly lightning strike can hit, originating from a storm that's hundreds of kilometers away. This makes traditional safety advice, like the 30-to-30 rule, seeking shelter if you hear thunder within 30 seconds of seeing lightning, inadequate. A megaflash can strike from a storm so distant you can't hear it at all. The safest advice remains: